Hi everyone, welcome. Honoured to be here in Sydney. Hi everyone who's watching online as well. Florian, I can see you in the comments. Greetings from Sydney as well. So today I'm here to talk to you about exploring the capabilities of Chat GPT. This is a very interesting topic for me. I've been sort of falling in love with Chat GPT over the course of the last couple of months. If you saw my last user group presentation 6 weeks ago in Newcastle, that was on GPT-3. And obviously the area is moving so quickly that only 6 weeks later, the whole thing had to be redone. So let me introduce myself to get started. My name is Callum Simpson, Solution Architect here at SSW. Been working here for about just over 4 years now. If you're interested in the content that I talk about tonight, I've got a LinkedIn and Twitter account. My Twitter handle is 5_ and then Callum. I have to tell you that because otherwise it just looks like a long line. But that was the least amount of underscores I could get, and have the full name of Callum in there as well. And LinkedIn, Callum JS. So I have been posting, if you're already following me, you'll know over the last couple of weeks, little sneak peeks at the content that I'm presenting tonight. So if you want to keep an eye on future content, that's the place to go. So a little bit about myself. I like to work smarter, not harder. I believe very much in that principle. The reason why is, if you think about it, working smarter is multiplication, working harder is addition. And there's only so many hours you can add to your effort in a day before you need to go to sleep, stuff like that. But if you work smarter, there's no limit to how much you can multiply your effort to get more outcome. I'm also pretty well known for my poorly timed talks, as I just said. So I did a Microsoft Dynamics user group a couple of years ago, and within a week, they rebranded the whole thing to Dataverse. And then 6 weeks ago, I did, as you know, the GPT-3 talk, and then the very next day, they announced GPT-4. So I'm expecting tomorrow we're going to hear GPT-5 coming out. Keep an eye out for that. So my primary objective for tonight is to introduce you to Chat GPT, talk about how to use it, what to use it for. This talk's going to be a little bit more technical than my last talk in Newcastle. The reason why is because the technicalities of how to use it have changed a lot, but the broader concepts of what you use it for are still pretty much the same, although we're definitely making a lot of progress down that road. The secondary objective that I've got, and I think the more interesting one, is to give you a glimpse of the future of development and everything else. So I probably don't need to convince the people in the room right now, but there's a lot of people out there who are still sort of only just hearing about Chat GPT, or maybe they have large reservations about using it. And what I want to do tonight is to lay out on the table all the different things we can do with it, and just sort of leave it to you to put those puzzle pieces together and realize actually we're a lot closer to, well, some pretty crazy things than a lot of people might expect. And I'll round that off at the end of the talk. Now, to get started, we've got an SSW app. You can scan that QR code there to download the app. You can get SSW points and get rewards. We're actually changing up the way it works tonight. So when you leave us feedback, or leave me feedback on the talk, you'll receive 500 SSW points. So we're making you give me feedback in order to get your points. Of course, you can leave feedback even if you don't want the points, because I really want to hear what you have to say about my talk, so I can improve it for next time as well. So I'll leave that up there so everyone can scan it. While you do that, hi Penny from Brisbane, hi Young from China, hi Luke, hi William. Hey, JK, nice to see you all here. All right, so let me introduce my agenda for tonight. So to start off with, we're going to look at some cutting edge AI developments. By the way, if you couldn't tell, this agenda was generated by Chat GPT. I just told it all the subjects. That's why they're nicely formatted with emojis and everything. So to start off with, we're looking at the cutting edge AI developments. Then we are going to explore the Chat GPT API. Then I'm going to talk about embeddings, unraveling the mystery of embeddings. Then I'm going to introduce Treasury, a Chat GPT content generation story. Then I'm going to discuss the rise of autonomous agents. And finally, that sneak peek into the AI-powered future. So first off, a look at the news. Adam already covered a little bit of news, but I'll just reiterate it for you. So Bing, the Bing chat, which is obviously Bing search with Chat GPT text generation, is now available without the waitlist, so you can hop on there and use it, as far as I can tell, without having to sign up for anything. And that's, like I said, Chat GPT with the Bing search results. It now supports the DALL-E image generation. So if you ask it to generate an image like that, generate me an image of a developer instructing dozens of AI-powered autonomous agents to build an app, and I can pick my favorite one there. There's the trademark misshapen hand that lets you know it's an AI-generated image, and obviously all the AI-powered agents in the background. Over at Google, obviously we had that sort of bungled launch where they had the video. The video had factual errors in it that sort of damaged their brand a little bit. They're obviously trying to be very careful about their product. Obviously, Chat GPT sort of captured everyone's hearts and minds, so they want to make sure that whatever they do, it has to be a lot better. Otherwise, they're going to be left behind. So they have a waitlist for access. I actually checked a couple of days ago. It didn't let me sign up because it said it wasn't available in Australia, but I checked again today and it was available. So that must be a new development that we can now sign up for that in Australia. They also have an API, which also has a waitlist. By the way, you'll notice that's sort of a repeating theme with a lot of these AI developments that are coming out at the moment. Is wait lists are very normal. So all these new things often have a fairly long wait list that you have to sign up for before you can get access. And so obviously they've lost their first mover advantage because ChatGPT with OpenAI is doing such a great job, and they need to really be the best product if they want to recapture any of that market share. Speaking of OpenAI, we've got the chat completions API. So that was the thing that came out the day after my last talk in Newcastle 6 weeks ago. So unlike the regular completions API, the chat completions is essentially the API that powers Chat GPT. So it works all with messages. You send messages in, you get messages back. The previous GPT completions endpoint would just sort of complete whatever prompt you sent in. So the new one is all about chat. If you've got Chat GPT Plus, you have access to GPT-4. It does rate limit you. Most of the time that I've checked, you've got 25 messages every 3 hours, although that is meant to be changing depending on how much load is going on currently. We've also got GPT-4 available via the API. Again, the W word of waitlist there. You need to sign up for the waitlist and wait to get access. Luckily, I do have access to the GPT-4 API, so I can show you some of that tonight. In my opinion, GPT-4 is a lot better. If you're just doing a simple task, it's going to be fairly comparable with the GPT 3.5, which was the previous one, but it really shines when you're doing more complex tasks, especially things like writing code, stuff like that. But you'll see as we get there. Just a quick note on that. So the GPT-4 model that's available in the API has 8,000 tokens, and that equals about 6,000 words. I'll tell you more about tokens in a minute as well. They've also got a 32,000 token model, and that one is, again, available via another waitlist. They're rolling that one out a lot more slowly because you can imagine the difference between 8,000 tokens and 32,000 tokens is quite substantial. They can't just give it to everyone straight away. They need, obviously, a lot more computers to process all that stuff. And again, just comparing this to the previous one, GPT 3.5, that one had 4,000 tokens. So with GPT-4, you've got at least twice as many tokens. But again, I'll explain about tokens in a minute. The other big news coming out of OpenAI is the Chat GPT plugins. So they released a blog post about this a couple of weeks ago. It's, again, on a wait list. It's the alpha version. But basically what the plugins are is they are third-party plugins that you run inside Chat GPT. You can ask it to do things like browse the internet or make a holiday or restaurant booking, do some e-commerce or whatever. Basically, these third-party API providers are making their API available in sort of a consistent way so that Chat GPT users can actually ask it to complete a task, and it's going to interact with that API that the third-party provider has made available. So that's pretty cool. There's a list of the current providers. So we've got things like Expedia, Instacart, Kayak, OpenTable, so on and so forth. And I would imagine that list is only going to get longer as time goes on. It sort of works like Bing. When you go to Bing, you ask it to search for something, it searches via Bing. This is basically the same thing, except instead of doing a Bing search, it's going to do a Expedia search and do an Expedia action, book a holiday or whatever it is that you do with that stuff. So yeah, that's definitely a very cool thing that's coming eventually. Like I said, still a very limited wait list though. All right, that's enough about news. Let's talk about Chat GPT. So what I want to do now is just sort of introduce the API for you in a bit more technical detail. So there's a platform.openai.com/playground. Mode equals chat. You can go to that link, and basically they've got a playground that works the same way that the old GPT-3 completions playground worked. So it lets you go in there, type in your prompt, you'll get your messages back as a result. I'll show you what it looks like in a second. So it's like regular completions that we had in GPT-3, but it's chat. So the whole thing is messages. You send a message in, you get a message back. It's basically the same as using Chat GPT via the user interface, except it's obviously an API. Now, the thing to remember that catches a lot of people off guard that I've spoken to is this thing is entirely stateless. So unlike the Chat GPT user interface, it doesn't manage any of your messages. Okay, so you as the client of the API who's integrating with it need to manage the whole message history on your side. And every time you want a new completion message from the API, you need to send in the entire conversation history up to that point, assuming, of course, you want ChatGPT to refer to those previous messages, and then you'll get the next message in the conversation back as a result. The other big difference, there's no fine tuning available. So it looks like we've sort of moved away from the fine tuning approach to these models. I think the approach is more that if we increase the amount of tokens that you can pass into it and get back as a response, rather than fine tuning it, we can actually just inform it with a bunch of reference data. And that way you can swap out that reference data whenever you want. You don't have to retrain a whole fine-tuned model. So I'll tell you more about that as well when we get there. So obviously, as a chat completion API, works for both single and multi-turn usage. So you can imagine that the same way that you would use the previous GPT-3 completions API for a single completion, as in you pass in a single prompt, you get a single response. That works just as well in chat. So you can pass in a single message and you get a single message as a response, but you can also use it as multi-turn, which means you send in a prompt, get a response, you can send in another prompt, and as long as you send in that whole conversation, you're going to get a response that sort of makes sense in the context of that whole conversation. The reason why we are recommending, at least for most use cases, to use chat completions, even if you're just doing a single turn, is because it's a lot cheaper. So the GPT 3.5 model is actually 10% of the cost of the GPT-3 model. And that's using the chat completions. The other reason, of course, is the GPT-4 model is only available through the chat completion endpoint. So obviously, if you want to use GPT-4, you need to use chat completions. So this is what the playground looks like. So if you go to that link, the platform.openai.com/playground and click on chat, you'll get an interface that looks something like this. So you can see here I've created a pirate chatbot. Obviously, all I had to do to create my pirate chatbot was put in the system prompt, "You are a pirate," and that's it. And then when I send it the message from the user, "Hey, how are you?" the assistant replies, "matey, I be doing well, blah, blah, blah." So it's talking like a pirate. All I had to do was give it one prompt. That's how easy it is to use the playground. I would encourage you to hop on there and use it and get familiar with it. It is pretty cool, pretty easy to use. If you want to know what's happening in the background, this is what the request looks like. So we're sending a post request to this chat/completions endpoint. Basically, what we passed in the body is a model. So we need to tell it what model to use, either GPT-4 or GPT 3.5 Turbo or whatever else you've got access to. So GPT 3.5 Turbo is the one that currently informs the free Chat GPT user interface. Then if you've got Chat GPT Plus, that would be using GPT-4. And then what we've got underneath that is an array of messages, and each message has a role and a content. So just like we saw on that previous slide, we've got a system message that says you are a pirate. The system message basically informs the behavior of the chatbot. So it's kind of separate to the conversation. The user message is obviously a message that goes from the user into the chatbot. The assistant message obviously is the message that comes from the chatbot back to us. So in this case, we define a system message and a user message. Obviously, we don't define the assistant message because that's the one that we're going to receive back as a response. Now, a quick note about other parameters. There are actually a lot of other parameters that you can use with your chat completion request. I don't want to go into too much detail about that for tonight, but I would encourage you to play around with it on your own. But I could easily do a whole nother talk just talking about what parameters to use. I don't want to get stuck on that all night. I would just quickly mention temperature. So this concept of temperature is another parameter that you can pass in. Basically, temperature is how much you want ChatGPT to make up stuff, essentially. So temperature is a number that ranges from 0 to 2. If you have it on 0, basically it's going to follow every instruction you give it very closely, and it's not going to sort of create any illusions like any fake URLs that aren't real, or create news that isn't really happening, anything like that. So you can see there, I've got a message with the temperature of 0. He just replies like a normal pirate. If I set it on 1, which by the way, 1 is the default, if you don't specify what the temperature is, you just get a regular old response as well. There's probably not a huge difference between 0 and 1, at least in this case, but you would see if you're asking it to generate maybe something with a more complicated prompt, the 1 would be more creative potentially. Then 1.5, you can see there it's starting to get a little bit maybe over the top with his pirate talk. So he's talking about, the wind in me sails, briny sea beneath me, me hearty, blah, blah, blah. So it's getting more sort of piratey as we go. And then you can actually go too far with it. So if I set it, for example, to 1.8, if you have a look at the end of it there, it just sort of turns into gibberish. Exactly, just like a real pirate. So there is definitely a limit to how far you can push it before what it says just turns into complete gibberish. So generally you can just leave it on 1 and you'll be totally fine, but it is interesting to play around with. If you want to try and tone it down a little bit and not create stuff out of nothing, you probably want to set the temperature closer to 0. And then if you do want to do that sort of stuff, probably closer to 1. All right, so that's all the stuff that goes into it. This is what we get back at the end. So this is just the message that we get back with the role as assistant, the content as the reply from the chatbot. And then, like I said, you as the client of the API need to manage the whole conversation history yourself. So if you sent in that message that said, hey, how are you? And then you got that response from the pirate bot that says, ahoy matey, and then the user has another message to send in to continue the conversation, what you need to do is pass in that whole conversation up to that point, including the new user message, in order to get another response from the API. So like I said, it's not stateless. Sorry, it is completely stateless. It's not storing any sort of information about your conversation. That's for you to pass in every turn. So yeah, like I said, the client has to manage all of the input messages. Now, the token limit is something you need to be aware of. So like I said at the start, GPT 3.5 Turbo, which is the old GPT 3.5 model that the free Chat GPT UI uses, has 4,000 tokens as the limit. GPT-4 has 8,000 tokens, And then obviously GPT-4 32K has 32,000 approximately tokens. Now, you're probably wondering at this point, what is a token? So I do want to give you a quick demo of that. So we've got this website here called the Tokenizer that I can access and bring it across here. So the Tokenizer is a tool that essentially lets you type text into this box, and it's going to show us what tokens are in that text. So I can just type something like, the Tokenizer assists us with identifying tokens. Okay, and then we can see in the area underneath, we've got 8 tokens in that sentence. It looks like all of those words are actually individual tokens except for tokenizer. So tokenizer is made up of 2 tokens. All the other words are made up of 1 token. And all a token is, from the perspective of the API, the OpenAI API, is it's just a sequence of characters. So you'll often see things like common prefixes and suffixes will be a token, and then maybe the base word will be another token, but it all just depends on the data that was used to train it. And basically these token IDs, if I click over to token IDs, these are the numbers that are used to generate the response. So we don't have to go too much into detail with how that all works, because that's sort of a black box for us, but that is sort of important to know at least how many tokens you're using. And there are, by the way, libraries available so that you can run your text through a function and it'll tell you how many tokens you've got. And then you can use that to manage your input text to make sure that you're not hitting that limit for your selected model. So back to the slides. Like I said, a token is a sequence of characters, and it's at the core of GPT. Basically, the statistical relationship between these tokens is how it does all its text generation processing. So, speaking of token limits, let's discuss a couple of methods of managing our tokens. So, see here, for example, we've got a conversation. So I've got the system message at the top, and then I've got a series of user messages and assistant messages. Say I'm storing this in the memory of my program. So what do we do if we realize that with the next user message that comes along, we're actually going to hit the limit of our tokens? So we have to do something, obviously, because otherwise, if we try and send in that whole message history with the new message that goes over the limit, we're going to get an error, right? So there's a couple of approaches we can take. The first one is simply just to prune out the earliest message, and so it will no longer be in that conversation history. We can just shift everything up and then chuck the last message on the end. And if you've ever had a very long conversation with Chat GPT, you'll notice that's sort of how that works, is eventually after talking enough, it's going to forget what was said in its earlier messages. So it also obviously has a sort of sliding window of context that is being sent to the API every time. And so once you say too much and you go too far below it, it's going to forget the stuff that happened at the start. There is another more complicated way that you can approach it as well, which is actually to squash a bunch of messages down into a summary. So same scenario, we've got the same conversation history here, but instead of just deleting the first message, obviously, by the way, we want to keep the system message no matter what, because that's what defines the whole bot behavior. So that's why we take the first user message out. But rather than just deleting it, what we can do is squish those maybe top 3 or however many we need to squish into a summary. So the way we can get that is actually take those 3 messages, for example, send it to Chat GPT and say, summarize these 3 messages. And then we have a summary of discussion, which we can put in a message in the conversation history. And then we've got plenty of room to fit another user message. So that brings up a concept that we will touch on again tonight, which is that conversation history, since it's entirely managed by the client, it doesn't actually have to be an accurate representation of the conversation that you had, right? You can sort of gaslight GPT to make it think that it said something that it didn't. All you have to do is pass it in as an assistant message, and it will think that that's what the conversation was. So obviously you can use it for more sort of useful things than just make it think that it said something that it didn't, and we'll get to that later on. So the next thing I want to talk about, I want to introduce you to my GPT-4 SharePoint web part. So the reason why I'm showing you this now is because it's the simplest example I've got for you tonight. It's pretty much just a basic integration with the Chat GPT API. If you don't know, a SharePoint web part is just sort of a widget that you can use in SharePoint, drag and drop it onto the page, and then it sort of is there for everyone who uses it. And basically, it's just a Chat GPT equivalent. So you're going to have your conversation history that you've had previously. You can open up a conversation, you can add a new message on it, all that sort of stuff. The reason why it's useful is Chat GPT Plus is required if you want to talk to GPT-4, or you need to have GPT-4 model access with the API. So I thought it would be useful if you have GPT-4 model access and you want to give maybe all your staff at a company access to GPT-4 without buying each and every one of your employees Chat GPT Plus, you can just give them access to this web part, and then they can talk to it, and they're talking to GPT-4. Although it is still rate limited. So this isn't a perfect solution because even with GPT-4 API access, it still doesn't like it very much if you send in simultaneous requests, for example. So if two people tried to use it at the same time, one of them would probably get a 429 error. So it's not a perfect solution. Now, the other thing I wanted to mention as well is the concept of GPT-4 driven development. So let me open up this chat thread here. So all of the examples that I created for you tonight, with the exception of the embedding example, which I had the help of Harry to put together for you, all the other examples that I've got for you were actually created entirely by GPT-4, and I did that as sort of a demonstration of how you can use it. So this is basically the conversation that I had. You can see how long it is. This is the conversation I had to create the SharePoint web part. Basically, I just said, to start off with, help me create a SharePoint web part that will replicate the Chat GPT interface. Then it's given me some steps to get started, setting up the development environment, blah, blah, blah. It's given me the code for the front end, which is all pretty good. And then it stopped there, so I had to say continue. It does that sometimes if the message is super long, but that's fine. And then it's got more instructions. You can see it kind of got mixed up with the code block because it had to continue. It continued outside a code block. Then when the code block was meant to end, it actually started, but that's not a big deal. Yeah, so then it's given us the style for the web part, how to test and deploy it. Then I realized I need an API to go with it. So we can't just have the OpenAI key sitting in the web part. We want to have an API that manages the key, and the web part talks to the API. The API talks to OpenAI. So then we're creating a .NET API in the background. It's given us the code to run all of that, blah, blah, blah. And it goes on for a long time. And the way I was using it, since we do have the 25 messages every 3 hours limitation, I was actually annoying everyone around me by sort of preloading all of these messages while I was out for dinner. So everyone else is trying to eat dinner. I was there typing on my phone, planning out the SharePoint web part that I was going to implement later. So when I got home from dinner, I already had all these code blocks ready for me. And all I had to do was copy paste them into my project, following all the steps. Once I did start using it, there were a couple of bugs. I think I talk about the bugs here. Okay, yeah. So for example, I was getting a weird response. I could have, used my brain and tried to debug it, but instead I just pasted the response in there and I said where it was coming from. And then it gave me the solution to fix the bug, so on and so forth. So then, okay, cool, it worked. Now, you'll notice in this chat as well, I do quite often remind it of, for example, here I remind it what my Swagger file looks like, because I knew that at this point it would have forgotten what the API code was. So it would have forgotten what the endpoints are, what the inputs are for those endpoints, all that sort of stuff. So in order to remind it what it was, I just pasted the Swagger file, and then down here, okay, and then it replied. Then after that, I can ask it to update the web part to use those endpoints. So once I had my API, I pasted the Swagger file, asked it to update the front end to integrate with that API. So on and so forth. This goes on for a while. There's the old front end code that I pasted in there as well, just to remind it. And then it replied me with the new front end code. I don't want to go through this whole thing, but I just want to demonstrate the fact that pretty much all the code was written by GPT-4. I didn't actually write anything. All I did was communicate to it the errors that I encountered, and then it was able to give me the updated code to fix those errors. And that takes me back to what I said at the start, which was how good is GPT-4? I think with GPT 3.5, the old model, I wouldn't be able to do that. Quite often, what it would do is make up random random software packages or whatever that don't actually exist. It would often have code that doesn't really work properly. So that's the advantage of GPT-4 is it doesn't have those problems. The code that it makes is a lot more cohesive and useful. And there's my web part in all its glory. I won't show you a live version because it's pretty basic. It's just the same as Chat GPT, except it's sitting in SharePoint. I will just quickly go through the architecture that I've got. So I've got a web part as the front end. So basically it gives you the list of chats at the top and then the current conversation in the area underneath. So obviously you can click on those chats to open them. You can type in the box at the bottom, click send, adds another message to it. We've got a .NET API that manages all the communications with GPT, and then it saves the result in the Azure table storage. And by the way, you might have noticed each of those conversations have a cool little name that sort of summarizes what the conversation is, the same way as it works in Chat GPT. And so the way I did that was when you start a new conversation and get a response, I actually have a little extra call to GPT that asks it to provide a title for the conversation in 5 words or less. And then I just take that and use it as the name of the conversation. So that's pretty cool as well. So you can sort of use it for multiple things at once. Just another reminder at this point. So it is entirely stateless. What you need to do is pass in all of the input to get your output. No memory of past requests, but you can obviously change the system prompt. You can insert fake conversations, and interestingly, we'll get to this in a minute, you can insert data from an API or from other sources. So there's no need to have the only data that you've got in your conversation come from either the user or a response from ChatGPT. You could just as well, based on the query, go grab some other API data, put that into the system prompt, and then use that to generate the next assistant reply. But we'll see that in a minute when I get up to it. Now, the other example that I've got, just a simple example to show you what we can do. This one, by the way, that SharePoint web part, that took me about 3 hours all up to develop, including the time that I was spending at dinner talking to GPT-4, which I think is pretty impressive. I mean, I don't develop SharePoint web parts on a day-to-day basis, so if I was to have to do that, for a client or whatever, it might take me like a week, something like that, because I'd have to go research how do I do it again, remember all the stuff involved, all that sort of thing. So I think turning a week into 3 hours is very impressive, and I was sort of blown away by that. But the next example I've got here is a GPT Outlook add-in. So the same sort of thing. I don't develop Outlook add-ins in my day-to-day job. I've never actually done it before. But the idea here was we want to generate responses to emails. Now, who can think of a problem if you pass in an email to GPT and just tell it to respond to it? Obviously, it's just going to randomly agree or disagree with the content. It's not actually going to give you the text that you actually want to reply with. It's just going to, based on whatever you sent in, it's going to give you a bunch of stuff that maybe it'll agree to something you don't want to agree to or whatever. So what we want to do here is actually guide the response based on some user input. And this might be coming soon with that whole Microsoft Copilot stuff. But I guess what I'm doing here is sort of a little preview of that because not everyone's going to have access to that right away. I imagine there's going to be a wait list on that as well. So why not just do our own one to get started? So here's an example. This is an email. I picked one that doesn't matter if I show it to everyone in the world, which is me earning a 3rd anniversary badge on the Power Platform community. So you can see my add-in has added that button in the top right of the screen there that says generate reply. And this is where the user guidance comes in. So I generate these 5 buttons, and these buttons represent 5 different approaches to responding to the email. So this is done sort of dynamically based on the content of the email. So we've got approaches like, thanks for the badge, tell me more about badges, love the Power Platform, too many emails, or not interested in badges. And then obviously I can pick one of those. In this case, I picked, tell me more about badges, and we get a response. Now, you don't have to bother reading it all, but suffice to say, there are 5 questions in there asking more about badges, which is what I wanted it to do. So that's pretty cool. And I'll show you how this actually works. So this is the prompt that I used to generate the 5 approaches. So I said, generate a JSON array of up to 5 strings describing different approaches to reply to the email, ranging from positive to asking for more details to negative. Include an emoji at the start of each response. Then I gave an example. So the example of what I want the JSON string to look like. Now, there are better ways of making sure that the data is actually formatted the way you want. Often it's good enough to just ask it to give you JSON. And you'll see at the end, I said, respond only with the JSON array, no additional content or commentary, because sometimes it would say something like, okay, here's your array, and then give the JSON string, which obviously when I try and parse it, it's going to fall over. So often just saying that is good enough, but there are ways that you can use some third-party libraries out there like LangChain to sort of chain this stuff together. I haven't bothered with that for this demo, but that is worth looking into as well. That again could be the subject of a whole nother talk. And yeah, make sure each string is short, up to 5 words is ideal. So that's what I sent in as the system prompt. And then I sent in the email content. And then obviously I get those 5 options. And then I can pick one. And then we go back to GPT a second time. This time we're generating a response. So the prompt is generate a response to this email following this prompt from Callum, and then email type. So that email type variable is just the text from the button that I clicked. And I have to say from Callum, which is me, because if I don't do that, it would sometimes generate a reply from a random third party or a reply from Chat GPT or someone else. So I had to remind it that it was from me. Obviously, if I was making this available to more people, I would look at who's the currently signed in user or whatever. But this is just for me right now. Ensure that you address all questions raised and elaborate in a way that is consistent with the style of the email. So I did that because if I didn't, if the incoming email is super casual, it would often give a very formal response to it. So you want to sort of match the formality based on what you're applying to. Format as HTML, use BR between lines, because if I didn't do that, it would use \ns to show all the new lines, which obviously doesn't work in an email. And respond from the point of view of Callum. Don't include a signature, because otherwise it would give a random Callum signature, which doesn't look good either. So yeah, that's that. I haven't made this code public yet because the Outlook add-in is a little bit buggy. It's kind of difficult to work with, and the installation process is pretty annoying. But I am working on that. So if you keep an eye on my Twitter and or LinkedIn, once I sort that out, it'll be there. The other examples I've got later tonight are in public repos that you can access later. So the next area that I want to talk about is unraveling the mystery of embeddings. So who here has heard about embeddings and knows anything about them? All right, we've got 3 hands up, and you 2 sit in the same room as me, so that's probably why you heard about it. So yes, not many people know about embeddings, and that's why I've called it the mystery of embeddings, because I think it's a very underestimated area that is actually very useful if you use it right. So what better way to explain the topic of embeddings than to ask Chat GPT? So here I've said, explain the concept of embeddings so simply that an idiot could understand. Not that I am one, of course. This is merely a hypothetical exercise, okay? And here we got a response. This response is a fairly good explanation, I think. So imagine you've got a box of differently shaped Lego and differently shaped and differently colored. You want to sort them in a way so that similar pieces are close together. So embeddings are sort of like placing those Legos on a table so that the similar pieces are close together and the different pieces are far apart. And in that way, you can easily compare and find similar Legos just by looking at it. So you can say, if I pick any arbitrary Lego on the table, the Lego next door to it is going to be the most similar Lego to that Lego. And I've created a little diagram for you to sort of demonstrate it a little bit more. So here we've got a range of color going along the top. So red on the left, blue on the right, and then a range of shape going up and down the page. So we've got circular at the top and I guess not circular at the bottom. And then we've got, your red circle in the top left, blue circle top right, red square bottom left, blue square bottom right. So then if we add, for example, a green circle, that's going to go in the sort of top right area, but not all the way to the right, but it's right next to the blue circle, right? So if I pick the green circle and I say, what's the most similar shape to the green circle in my set of shapes? Obviously the answer is the blue circle, right? And then, we've got a yellow dodecahedron that's sort of, trust me, I counted, that means 12. There's a yellow dodecahedron in the middle, right? So it's sort of halfway between a circle and a square, I guess. And it's halfway between red and blue, sort of, as well. So that's basically how it works. It's basically plotting an item somewhere in space based on its attributes, and then being able to find similar ones just by looking at where it is in the space. So yeah, on the topic of actual embeddings though, we're obviously not talking about Lego or colored shapes. We're talking about words or phrases, or in fact essays. So you can actually embed up to 8,000 tokens, which is approximately 6,000 words at once. All of that gets boiled down to one single point, or vector, I mean. More on that in a sec. So there's a 2D table in our Lego example and our colored shape example. In the world of embeddings, we're actually dealing with multi-dimensional space, which is, at least for me, a lot harder to visualize. But for the OpenAI embeddings, we've got 1,536 dimensions. So basically, each embedding is an array with 1,536 numbers in it, and those numbers indicate the sort of location in multi-dimensional space of the embedding. And so in our example, we had a 2D point. So it had a point based on the color, point based on the shape. With embeddings, we've got 1,536 dimensional vector. And then instead of just comparing closeness with our eyes, as we can do with the colored shapes in the thing, there's this function called cosine similarity. Don't worry, I'm not going to get into the maths because I barely understand it myself, but suffice to say, there's a function called cosine similarity. You pass two embeddings into the function and it will return you a number that indicates how similar or how close those two embeddings are. So if you want to find the closest embeddings to a given arbitrary point, you can just compare, using the cosine similarity function, that embedding with every other embedding in your data set, and it will return you a list of results with similarities. You can order them from most to least similar, and that's it. So that's basically how you use the embeddings. Instead of looking on the colored shapes, you use the cosine similarity function. Here's an example with text. So just to sort of drive this point home, we've got some text here, the cat chases the mouse, the kitten hunts rodents. So that text is obviously quite similar to the first one. So they are located next to each other in this 2D space. I like ham sandwiches. Obviously a very different sentence. So we're going to put that one all the way down in the bottom right. And then I like cats. Maybe that goes somewhere in the middle because it's sort of related to cats, sort of related to things that I like. And then maybe I like dogs is sort of off to the side, right? So obviously I've sort of mapped that onto 2 dimensions, but there should be 1,536 dimensions. I'll leave that to your imagination to envisage. All right, So what can we actually use this for? Has anyone got any ideas? Harry, yes. Search engine, yes. Good idea. So semantic search, you're right. So the reason why this would be useful for semantic search is in a regular search, what you would do is take your search string and then find, maybe you've got a set of documents, you want to find the documents that contain that substring in them, and then just return those as the search results. The reason why it could be useful for semantic search is rather than just searching for that substring in all of your source documents, you can actually find which source documents are most similar to the search string in terms of meaning, not just content, right? Because you'll take the embedding of your search string, you would have already pre-indexed all the embeddings of all your documents, and then you can just find, all right, which documents are most close to my search query, and those are my search results, right? And we're not then looking for a specific substring, we're actually checking the meaning of the search query versus the meaning of each of the documents. Another use, document clustering. So if you've got a whole bunch of documents and you want to know sort of which documents are similar to each other without having to go through and manually tagging each one as, this is such and such a document, that this one belongs somewhere else, blah, blah, blah. You can just sort of map out all the embeddings and then use a computer to calculate. Maybe you'll specify, I want 10 clusters. It's going to cluster them based on how close they are in this embedding space. And you can then inspect what those clusters are and tag them appropriately. And that's going to save you a whole bunch of time. Another one, recommendations. So, if you know what documents someone likes, obviously you can easily recommend them similar documents based only on the content of the documents. So you don't have to do any sort of extra processing or any extra stuff like that. It'll just be based on the embedding of the document and the embeddings of the document the user likes, which ones you recommend to them. Cross-lingual tasks. So this is a really big one, sort of a hidden superpower of embeddings, is the fact that it deals with semantics or meaning rather than actual content, means that if you, for example, had a search with a Chinese text, some Chinese characters, it would still be able to tell you which English documents are most similar to that Chinese text, because the embeddings work based on meaning and not on the actual text. So it's still going to embed that Chinese string in the same space as the English documents. And the Chinese string, if it's similar to the English documents, it's going to be nearby and it's going to return those as results. And I'll show you that in a minute. And of course, the other one, and the reason why we're all here tonight, is the chatbot. And that's what I'm going to show you right now. So embedding use case for chatbots. So why is it useful for chatbots? Well, like I said a few minutes ago, we can provide specific information into the system prompt, right? So we can take the embeddings of the user message that the user has sent into the system, find what documents are similar to that user message, and then put those documents into the system prompt. And then when GPT writes its response, it's going to be informed by those documents. So this is useful, obviously, if you've got something like, maybe an online store with a whole bunch of products. You calculate the embeddings for the text description of all the products. Then when a user says, give me a product that, I don't know, maybe it's a clothes shop, give me a product I can wear on a sunny day, I like the color red, it's going to generate a list of similar products to that search query, and then it's going to inform GPT, these are the products that we've got available, these are their features, write a response to them with that in mind. And then it can respond something like, okay, we've got product A, product B, product C, they might fit your requirements or whatever, right? So the reason why this is cool is you don't need fine tuning. So this is why fine tuning is sort of no longer the way that we're tweaking these bots to give specific information, because rather than fine tuning it, which used to be where you'd sort of pass in a whole bunch of expected input and expected output, instead you can just use the same model every time and just change what you're putting into the system prompt. And as long as you've got enough tokens available, it doesn't really matter that you're not fine-tuning the bot. And yeah, like I said, so out of the box, semantic cross-lingual support. You don't have to do anything extra to make it support different languages. And the way GPT works is if you give it an input string in Chinese, for example, it's going to give a response in Chinese as well. So even though all your source documents could be in English, if a user queries it in Chinese, it's going to get the related English documents to that Chinese query, inform the response, but the response is also going to be in Chinese in that example, or whatever language was input. So that's pretty cool. Now, what we have used it for today in our demonstration, this is what Harry was working on for the last 2 weeks, is for the SSW rules. So SSW rules are a set of best practices on a whole range of topics related to software development and many other things. So what we did was we actually took all those rules, ran them all through the embeddings, and then we used it to inform a chatbot. So the chatbot is going to be able to respond to user queries, and it's going to be informed by rules. Here's an example rule, just in case you don't know what SSW rules look like. I'm just going to show this to you. So this example rule here, do you know when and how to send a V2 of an email? And then we've got a whole bunch of text that explains a V2 email. So at SSW, we've got a concept of a V2 email, which means basically if you send an email and you realize you've got a mistake in it, you send a V2 email, which means instead of replying to it saying, hey, I stuffed up, here's what I meant, or whatever, you just basically resend the original email. And that's sort of an internal practice that we've got here. And this is the rule about it. There's a whole bunch of other rules if we go back up here. So there's all these different categories of rules, and you can check them out at your own leisure. But what I want to show you tonight is what we did with those rules to make an SSW rules bot. So firstly, this is what the embeddings endpoint looks like. So essentially, you just send a post to that URL, you put your text in there, so your input text, the model, the text embedding adder 002, that's the best embedding model to use for in terms of both how good it is and how cheap it is. By the way, the whole process of embedding all the SSW rules cost about 20 cents. So it's super cheap. If you watch my last user group, you'll know the cost of fine-tuning the rules generator, which was one of the demos I had last time. So I basically fed in all of the rules data to fine-tune it to make a model that would create rules for me. That cost about $200. So this is the same amount of content, and it costs 20 cents instead of $200. So it's a huge amount cheaper. And this is what the response looks like. So this is that 1,536 dimensional array that I was talking about. Those numbers go way off the screen into the center of the earth sort of thing. And the cost is 0.0004 US dollars per 1,000 tokens. So that's super cheap. So just to show you sort of what the process looks like from start to finish, when we've got a user message coming in, we will calculate the embeddings of that user image. So we're plotting it in that 1,536 dimensional space. Then we take that point, and then using the cosine similarity function, we compare it to all of the rules that we have already calculated. So then we know which rules are most similar to what the person is asking. So obviously, if we know what rules are similar to what they're asking, we can give them a response that actually answers their question with reference to the rule, right? So that's why that's useful. And then all we have to do is put those rules into the static message, and then we get back, or we get from that the system message that's informed with the references. So then when we combine that with the original user message, the response we get back from Chat GPT is going to answer the message, and it's going to answer it with reference to the rules that are related to the query. So that's why it's useful. Here's just another sort of demonstration. So what we've tried to do here is sort of flatten out that 1,536 dimensional space onto 2 dimensions. so you can sort of visualize it. So the example here is we send in the query, how do I send a V2 email? And then it's sort of lighting up this sort of, all these points here, each one is an individual rule, and it's lighting up how similar the rules are. So if I ask something like, how do I send a V2 email? We've only got a couple of rules related to V2 emails. So those ones light up. All the other ones don't light up because they're obviously not related. So those two rules that are turned red, we know that those are the ones that we want to send back to the user, and all the other ones we don't really care about because they're not related to this query. And then, we've just got a couple of other examples. So if I typed in, give me some tips for a better user group presentation, not that I was, looking for any particular reason, it lights up a whole bunch. And the reason why is a lot of these different rules talk about user groups and presentations and those sorts of topics. So there's actually quite a wide range of rules related to it. You might be wondering, why are all these rules all over the place? I thought they were meant to be close together. That's just a part of the reason why it's meant to be in 1536 dimensions. When you compress it into 2 dimensions, even though they're close together in lots of dimensions, they sort of spread out when you squish them into 2. That's why. And here's another one. How can I get Scrum working with my team? So the top rule is the rule about Scrum guide, and then we've got a whole bunch of other rules about Scrum and teamwork and working and whatever else is semantically related to that. So here's a bad example of what does the chatbot do if you ask, how can I send a V2 email, and you don't give it any rule information. So this is the generic response. And you can see here, I explained what a V2 email is, right? It's what you do when you make a mistake in your first email and then you want to resend it. But the instructions that it gives me with no reference data is actually just instructions to send a normal email. So it doesn't understand what a V2 email is, and that's because it's something that we do at SSW. It's not like a commonly known thing that would be in the training data of the model, right? So that's why we can insert the reference data. So here I've done it again, but this time in the reference data, I've inserted the rule about how do you send a V2 email. And I'm just doing this in the playground to demonstrate it, but this is how the thing I'm about to show you works in the background, right? So based on the incoming query, we calculate the embeddings, find that this rule here is the most similar one, and then we just pop that in the system prompt. And then you can see the response that we get from the assistant is a lot better because it's now informed by that reference data. It's now explaining how to send a V2 email following the SSW rules. So that's why it's so cool. And here's the cross-lingual example. So I'm reliably informed that this query here is how do I send a V2 email in Chinese? I don't speak Chinese, so I don't know, but that's what it says apparently. And then you can see with no additional changes to anything, it's got exactly the same system prompt. The assistant has responded in Chinese how to send a V2 email. Now, I'm also told that the Chinese is not like super great. It's not like at the level that maybe a fluent speaker would use, but it is at least understandable. So it might not be as good as maybe Google Translate, but I would say that's probably because of a lack of training data on Chinese. And if they wanted to make this a good Chinese bot or whatever language, it just needs more training data, basically. So its English is a lot better than its Chinese, but yeah. So there's no additional, basically anything that I have to do. All I do is send it the user query in Chinese. It responds in Chinese, the same information as English, referring to the same data, but no additional work required. All right. So another thing that I want to talk about just quickly is the art of embedding granularity. So the concept of embedding granularity refers to how big of a chunk do you actually break it down to. Hang on, I just saw a chat in here from Young, who's Chinese. She said it's totally understandable and better than Google Translate. So that's good to know. So it might actually not be that bad. Who knows? Anyway, so moving on. So the art of embedding granularity refers to how big of a chunk do we break our source text into to calculate the embeddings. So remember, each point in that diagram I showed you earlier was a document, but how big of a document do we use? Because it could be as long as 6,000 words, but it could also be a whole lot shorter as well. So there are pros and cons to using long text for embeddings and short text for embeddings. And that's something that's sort of like, I call it the art of embedding granularity, because it's sort of like an art as much as a science. And it needs a little bit of experimentation to get the best fit for your need. So with the longer embeddings, so for example, if we were to embed an entire rule in one go, you get a lot more in the way of context and tangential concepts. So sort of related tangentially to the concept of the rule could be taken into account when it's mapping its position in that multi-dimensional space, but you're also missing out on some finer levels of detail, because you have to remember, no matter how long your input text is, it always maps back to 1,536 numbers in an array. So if it's one word or if it's 6,000 words, it still just corresponds to 1 point. So obviously, if you've got one word, you've got 100% of that word is informing its position. If you've got 6,000 words, then only, 1/6,000th or whatever of each of those words is going to inform its position, right? The other thing to keep in mind is token wastage. So if you've got really, really long documents and you're inserting them into chatbot references, a whole bunch of that document that you're inserting is not actually going to answer the user's question. So it's just going to be wasting tokens, and obviously tokens equals money. So we want to sort of minimize how many tokens we waste so that we're not, giving it extra stuff that it doesn't need to know to answer the question. So here's an example of that. So a really long embedding will be taking the entire rule and turning it into one embedding like that. Then on the other hand, we've got short embeddings. So the bonus of using short embeddings, we've got that fine level of detail. It's token efficient as well, obviously, because it's not going to send in a whole bunch of extra text that isn't related to the query. But you're going to miss out on things like a lack of context, a lack of relationships between context, between concepts, that sort of thing. So examples of short embeddings would be, you actually take maybe you break it down something like that, and you make each one of these its own embedding, and then based on the user query, you find which one of these mini blocks is relevant and return those in that reference data, right? So you can imagine if you're a chatbot and you only had access to that, would you have enough information to answer a query? That's what the approach you need to think about when you're deciding how big to make these documents. So in our example that I'm going to show you shortly, we went somewhere sort of halfway in between. So we sort of broke it into paragraphs of decent size. If it was a really small paragraph, I think we grabbed a bit more information. So we did experiment a little bit with the best size, but it really depends on what your use case is, what the best size would be. So there's no one size fits all sort of thing. Now, a quick side note as well about vector databases. So just like a normal database where like a SQL database or whatever, where you need to store a whole bunch of data, these vector databases are sort of aimed at supporting vector queries. So things like the cosine similarity function, rather than having to calculate it all in memory, you can use these databases and store all your, in this case, SSW rules and their embeddings, and then you can just query it, and it will return you the most similar rules without you having to implement your own cosine similarity function and hold all that stuff in your own memory, and things like that. So they're definitely worth investing in if you are doing something like this. There's a few options out there. There's Pinecone, which is a popular one. In our case, we're using Supabase, which is running a Postgres with PG Vector plugin. But there's a whole bunch of options out there. I'll let you do your own research on that. This is what it looks like in the backend view. So you can see we've got columns here. We've got a column for ID. That looks a little bit fuzzy. We've got a column for name. We've got the content of the rule, and we've got the embeddings array. So basically what we do is we calculate the embeddings of our query text, we send it to this, and we basically just tell us, give us the most relevant rules chunks based on this embedding, and that's all we need to send it. And then it gives us back and we ask for the content, obviously. Then we get the content back, and that's what we put into the chatbot. And you can see here, for example, down the bottom of the screen, there's a bunch of 8 steps to Scrum chunks in there, and that's sort of evidence of the fact that we broke rules into several chunks, especially if they were longer, based on how many paragraphs are in the rule. So so again, the reason why we do that is because not all the rule is going to be relevant to any given user query. So to make it more efficient, we just want to give the chunk of the rule that is relevant to the query. So here is my demo of this running on my own machine at the moment. So what I can do here is I can type a message into this box, and it's going to respond to me with a response that is informed by rules. So I can say something like, give me tips to running a better user group presentation. Send that. Okay, and then it responds just like Chat GPT. So by the way, this is another option that you've got when you're implementing the Chat GPT API, is you can ask it to stream the responses, and that makes it come back word by word using WebSockets. That's a little bit more complex, so I'm not going to go too much into detail on that, but you can look that up yourself. If you want it to come back word by word. Otherwise, we would be waiting here for it to write this whole thing on the server side, and then only when it's finished the whole message would it come back, which is kind of awkward if I was doing that for a live presentation, because I'd just be standing here waiting and hoping that it was actually going to work. So yeah, we can see here it's answering with information about various rules. So, be prepared with venue details, inform the speaker about projection options, let them know the event schedule and when attendees will arrive as per that rule, engage in content delivery, keep your presentation content well structured, relevant, rehearse your delivery, make it smooth and confident, keep it simple, stick to the KISS principle. Obviously, go to real rules. There's the rule that that relates to. So I can then sort of look up to get more information by clicking on those links. And the reason why it's giving those links, obviously I'll show you the prompt in a minute, but in the prompt, we ask it to give a link back to the source so that if the user wants to get more information, they can see it. And this is something I asked Harry to add in this morning. Thank you, Harry. So we've got here sort of a little preview that shows us what information is being put into the system prompt, just so you know where it's coming from for the purpose of the demo. So based on my prompt, which was give me tips to running a better user group presentation, it's found these rule chunks from the database, and it's just put each of these into the system prompt of the chatbot, and then it's asked it to respond to the query with that rule information in mind. So yeah, I think that's pretty cool. Does anyone have any queries they would like to test out for us live? Harry? Zoom in. Oh, sorry if you can't see that. Let me zoom. Oh, that's right, yes. How do I send a V2 email? Yeah, so there you go. Another thing that I'm telling it to do in the prompt is I'm asking it to use a lot of emojis, because we're big fans of emojis here at SSW. So you'll notice there's a whole bunch of emojis sort of strewn around the response. And we're also big fans of sort of numbered task lists. So you'll notice it's sort of giving a numbered list of tasks in order to achieve whatever I'm trying to do. And that's part of the prompt. So even if the rule information doesn't include sort of a step-by-step approach, it's going to try and convert the rule information into step-by-step approach to answer the query. And yeah, so that there is just giving us instructions on how to send a V2. It's got the link to the rule there that I can refer to, which is cool. And yeah, that's it. Yes, so I'll jump back to my slides. Yeah, so here's the query that I'm using. So it's quite a long query. This query I sort of had to work on a fair bit to make it give reliable results. I guess a bit of prompt engineering there. So you can see at the start there, I'm saying who it is. So you are SSW bot, helpful and friendly and funny bot. You like to use emojis throughout your responses. You answer questions that users send in. I tell it to summarize the reference data rather than copying it verbatim, because if I didn't do that, it would often just repeat the exact text that was in the rule. But you wanted it to sort of, process a little bit and present it in maybe a more funny or fresh way, depending on how it was asked. I asked it to tell a relevant joke now and then. Here's where the numbered lists come in. So I say, if you have specific instructions to complete a task, make sure you give them in a numbered list. If the request suggests the user wants to make an action, guide them towards completing that action. For example, if the person is sick, they'll probably want to take sick leave or work from home. So sort of figure out what their intention is and try to guide them towards doing whatever that is that they want to do. Reference data based on user query. So that's where I put in all of the related rule chunks based on the embeddings of the query that they sent in. Summarize the above, prioritize from most to least relevant without copying anything. So I often find as well with these prompts, you need to sort of repeat the important facts sometimes. So you'll notice I mention at the start and then repeat it again at the end. So in between, it's got all that reference data that, even though it looks really short there, it's actually extremely long, a whole bunch of rules. So repeating it at the end just helps to remind it that's what it has to do. Otherwise, it can forget because the prompt is so long. Then we have a format that we need for emails. And that at the end there, you should use the phrase as per the URL/rule name. So that's why it has all these URL links that we can go to and click on, because I explicitly ask it to give a reference in that format. And don't forget emojis, include one reference if relevant, etc., etc. So so yeah, you can see there that embeddings sort of do the same thing that fine-tuning did, except I would say in a better way. The reason why is, well, I'll tell you the reason why in a minute, but first let's compare them. So embeddings, the advantages of embeddings are there's no work required once trained. Okay, there's an error on my slides because that's meant to say fine-tuning. So the advantages of fine-tuning are there's no work required once you've trained the model, and there's no limit on how much you can train it. The disadvantages of fine-tuning, apologies for the incorrect label, is that it's a lot more expensive. So it costs $200, for example, to train it on all the rules. And if your data changes, so whatever you fine-tuned it as, if that internal process or whatever changes, what do? You need to sort of unfine tune the now incorrect information and refine tune it with the new information. So that's why embeddings, got to swap those around, sorry. Embeddings, you have full control over the data that goes in. It's always up to date because every time we do it, we grab the information from that vector database and inform the system prompt. So if any of that internal process changed, we would just grab the new updated information from the database and chuck it in there. And also it's cheap. So 20 cents versus $200 is obviously extremely cheap. The only downside, I guess, of the embeddings approach is the extra work involved and the token limit. So there's only so much information you can provide it with each request. So with fine tuning, you can fine tune it however much you want. With embeddings, you can only pass in so much. But with the rate that these models are increasing in size, 8K to 32K and so on, it's probably going to be less of an issue. All right, so that's it for the embeddings. So the next thing I want to talk about is Treasury, a Chat GPT content generation story. So Treasury is my blog about tea. So you can access it on treasury.com. You're welcome to go check it out right now. And what this blog is, I don't know anything about tea, by the way. What this blog is a content generation experiment, because the entire blog is actually created completely by GPT-4. So it's got all sorts of articles on there about all sorts of different aspects of enjoying tea and so on. And all those articles are completely written, including the topics and including the images, completely created by either GPT-4 or DALL-E for the images. So I like to think of it as sort of a Turing test in blog format. So what I'm trying to do with this blog is just run an experiment to see if anyone who doesn't know how the blog is made is able to pick up on the fact that it is generated by GPT-4. So I would encourage anyone who's watching to maybe share it with a family member or something. Don't tell them the story, obviously, and then see if they are able to pick up on it, or if you need to tell them what's going on. So I want to show you firstly what the actual process looks like, and then I'll explain how it works, because it does take a little bit of time to work. So basically, the Treasury repo here, this is just a private repository that I've got, and it's just a Next.js site that hosts a blog. The blog is based on these posts. So each post is just a markdown page. It's got a bit of front matter with the metadata, and then it's got the markdown formatted blog. And what I'm doing with my GPT-4 integration is every 2 hours, I've got it creating a new blog post for me. The blog post is added in a pull request. So you can see I've been a little bit slack and let these pile up. I've got 55 outstanding pull requests because it's running every 2 hours. So every 2 hours, it creates a whole new blog post for me. The blog post, we can review the content like this. So this blog post here is about tea botanicals, infusing your brew with aromatic enhancements. And then we've got a date, author, tags, and then we've got a whole blog post. So you can see it's just formatted in Markdown like that. And it's also generated this image. So the image, I think, is the biggest giveaway of the fact that it's computer generated, because DALL-E doesn't do text very well. And so often the images, if they have any text in it, it's very obvious that it's not done by a human. But I think the text itself is a lot better. So this entire blog post here is created by GPT-4. Now you might be wondering what happens if it creates a blog post and there's something in it that I don't like or I want to change or whatever. So I do have the ability to edit this stuff as well. So not editing myself, obviously, because I don't want to engage my brain, but I just want to give it instructions. So what I can do is actually leave a review on the pull request. And then I've got another integration with GPT that picks up my review and regenerates the entire content based on my feedback. So I'll show you an example of that right here. So what I can do, for example, is maybe I'll say like, add a hilarious pun to the introduction. I don't want to think about a pun. I know that I want a pun. I don't want to think about it though. And then let's do another one. So here, I want to have a heading for the conclusion as well. I don't like the way that it just sort of ends like that without a conclusion. So let's say add a conclusion heading down here. Okay, and just like that. And then once I've given it all my feedback, I just submit the review. And then that goes away and updates it. Now this bit takes a few minutes, which is why I do that first, and then I explain it, then we'll come back to it later. So we'll leave that cooking in the oven. We'll jump back to here. So just more on the fact that it's a Turing test in blog format. So I actually have been trying to advertise this blog. I've added some interaction stuff. So I've got a discussion area at the bottom. I've got reaction things. I've got a share on Twitter button at the top. I've been advertising on Twitter. So I spent $30 advertising tweets that I wrote about different blog posts just to try and get someone to visit it. I got, I think, 30 visits, but I don't have any comments yet. So that's why I'm encouraging everyone watching to try and get people to look at it just to see, because I am curious, I'm sure you are too, to see if people who look at this thing are able to tell immediately, hey, this is just computer generated nonsense, or do they think this is actually interesting? I have actually been enjoying reading my own blog. I think the articles are actually quite interesting because obviously I'm looking at them for the first time as much as anyone else is. So yeah, I think it's pretty interesting. I actually want to show you what it looks like as well while that thing works its magic there. So I'll go to it right now and show you. So this is what the blog looks like. So we've got some interesting articles here. Tea in literature, brewing imagery and metaphors in classic works. You can see, by the way I sort of display the image, I'm trying to cover up as much as possible what the actual image looks like, just to sort of try and obscure the fact that it is obviously computer generated. But yeah, so yeah, I've got a share on Twitter button. I've got some interesting article here about different literature and how tea is associated with it. I think it's a pretty good article, but since I know how it was made, it's not that interesting. But yeah, that's what I'm trying to figure out, is if someone saw this without knowing, would they be impressed, or would they just think it's crap? So that's what we want to try and find out. Anyway, back to my presentation. So you're probably wondering how it works. That's the next thing I want to show you. So I've got this repository here called the GPT Auto Blog Writer. I have made this repository public, so you're welcome to check it out and have a look at how I've done it. But I'll give you a quick rundown to start with. Basically, it's 2 Azure functions written in C#. One of them is run every 2 hours. That's the one that generates the first blog post to begin with. So I'll show you that one here. Generate blog post. And essentially what it does is it clones the repo. It creates a new blog post here with this write blog post function. The prompt for that is just, you are a blog writer for my blog on T called Treasury at ttreasury.com. It's all about T. By the way, this is a very innocent T blog, right? I'm not trying to make any money or anything out of it, but it could very easily be tweaked to say, advertise my T product that I'm selling on my store or something like that. So I think it could very easily be turned into something more useful, but I didn't want to do that for this example. I just want to show you what you could do. And then feel free to be controversial in order to drive engagement, because I was really trying to get people to have strong opinions on it. Use Markdown when you create the page. So I'm just telling you what format to use. Don't use a title because that gets added separately. Use an occasional pun or thoughtful personal remark in the introduction or conclusion. Encourage people to engage with the discussion area. That was something I added as well to try and get more engagement. And then we've got our front matter. So I just give it an example of what the front matter looks like. That's all I have to do. It hasn't failed to generate that format yet, so it seems pretty reliable. And then what I also do is I give it a list of existing posts. So this is how I make sure it doesn't repeat a topic. Every topic is unique and new. And the way I do that is I just give it a list of existing post titles in the conversation history, and I instruct it to write a blog on a brand new topic not listed. So basically we're telling it, these are all the ones you've already done, do something new. And that way we make sure we don't repeat any subjects. And then we just create that blog post. We create an image with DALL-E, which basically just takes the title of the post, sends it into DALL-E, gets an image back. Then we put those files, the Markdown file and the PNG file, into a branch. We create a pull request on the branch, and that's it. And then on the other Azure function, so this is the one that is triggered when I leave a pull request review. So this one is just triggered by the GitHub webhook. So there's a webhook that you can set up when someone leaves a pull request, triggers a webhook that goes into this function here. And all this one does is it takes the comments that were left on the blog post, and it repeats a pretty similar prompt to the last one, but it also sends in a list of comments. So it says there's a comment on line X, and the comment is this. So that's all you need to do to tell it where the comment is in the context of the blog post and what the comment text is. And then based on that, it's able to create a whole new post edited as I want it. So I think we probably, okay, it hasn't finished yet. Let's refresh the page, see if it's going to update. It looks like it's still going. So yeah, it does sometimes take a while. You can imagine it's going to take a while for the reason that the edit one especially, it's got all the tokens that are in the input. It needs to generate all the tokens that are in the output. So there's a lot of tokens that it's going through. It's costing me about $2 a day to generate a blog post every 2 hours. So that's quite expensive when you think about how most of these things are, sort of cents rather than dollars. And yeah, okay. So what I'll do is I'll just show you a previous one that does have some comments rather than just sitting around here and waiting. So here. So this one I did a few days ago. On this one, I know that it worked, by the way, because it has 2 commits. So it does one commit, obviously, for the initial blog, and then it has another commit for the update. So what I asked it 3 days ago, this is when I was doing a test run of my demo, I said, add an extremely lame pun to the introduction and add 2 more rows to a table. So I've got a table in the blog post. We just want to add 2 more rows to it. So part of the update Azure function is it actually adds a comment as well. So I added this because I thought it was kind of cool. Add a comment that explains what changes you've done in the edit. So it adds a comment to the pull request explaining what it did. And then if we look at the second commit, we can see that it has added an extremely lame pun. And that is really lame. So it says, after all, there's no time like the teasant. So I think that's meant to be like present, teasant. Yeah, so that's a really bad pun. I did say extremely lame, so it ticked that box, I guess, to discuss our favorite brews. And then it also added these 2 extra lines to the table. So you can see there, it's basically done what I asked it to do. And eventually the other one that I did is going to work, but we don't have all night to sit around waiting. So we'll leave it to do its thing. So yeah, again, that code is publicly available in that repo. You're welcome to check it out and use it for your own purposes. And that's just a quick look at what the prompt looks like. We already went through that. This is the structure of the project, just to sum it up for you. So I've got a Next.js site that serves markdown files as blog posts. It's hosted on Vercel, which is useful because Vercel gives you a preview of all of the branches. It gives you like a preview site. So if I want to preview what the blog post is going to look like, just to make sure that it, formatted the markdown correctly and whatever, I can just hop in there and have a look at the preview. Pretty cool. We've got a GitHub repository where we have all of our content. We use PRs to manage new content. So each new post goes in a new PR. I add a comment on the PR when I want to request changes to that blog post. And then we've got these 2 Azure functions that sit in between GitHub and GPT. So our first one runs every 2 hours, creates a new markdown file and PNG file, adds a new branch, submits the PR. Then the other one gets triggered when I leave a review on the PR, and it does the whole editing process. Yeah. So that's that. All right. So next thing I want to talk about tonight is the rise of autonomous agents. So who here has heard about Auto GPT or Baby AGI, anything like that? All right, we've got a few hands up. Not everyone though. So this is sort of a new thing. First off, I want to introduce you to my stab at this kind of thing, which is again in a public repository you're free to have a look at. It's essentially a PowerShell script um, that generates PowerShell commands based on input. So say you wanted to achieve an arbitrary task with PowerShell commands, this thing actually, based on the input that you give it, it's going to generate a series of PowerShell commands that it then runs in the context of PowerShell, gets the result of the command, and feeds the result back into the input of the next step. So it's kind of like a perpetual loop of running a command, processing with GPT, the result of the command, and deciding on what the next command to run is. So if you want to see how exactly it works, it's all here in this public repo. But I did it in the context of PowerShell because that was the easiest thing to do if we're running PowerShell commands, to run it as a PowerShell script rather than something else, because otherwise we need to convert it into PowerShell or whatever every time. So basically how it works is we start with a goal. So we define the goal of our script. We break that goal into a list of tasks, and then basically we run on a loop, so the result of a task becomes the input to the next task. And we just keep doing this until our overall objective is complete. So we're keeping track of the overall goal and the progress towards it. So here's an example of it running. I don't actually want to run it live because it does do sometimes some weird things on my computer that I don't necessarily want it to do because it's running random PowerShell commands. But basically here I've given it the command create a Node.js app that will return the reverse of a provided input in a GET request. So a pretty simple Node.js app, but just something to demo it. So these white lines here in the image are basically explaining what it's doing each step. So step one, create a new directory and initialize the Node.js project. So it's just run some PowerShell commands to create a directory, initialize a project. The next step was install Express.js and create a file called index.js. So inside that file, that directory that it created in step one, it's running npm install express and new item file index.js. So it's created the file. The next one says write the Express.js code to handle GET requests and return reversed input. So the next line, we are inserting content into that file that will reverse whatever the given input is. Then the final one is just run the Node.js app. And then I ran it and tested it and it worked. So you can see here, I went to that URL and it reversed hello because that's what was in the query string. So that's all I had to do to write a Node.js app that reverses the input. Obviously a super simple example, but the point is it is able to sort of loop through a series of conversational turns. In fact, the way it works, the way I set this up, is each of these inputs and outputs is actually another message in the conversation. So that way it can remember what previous results it had. It has the full context of what it has done in the past, and that's how it knows, for example, where the index.js file is to insert the content into it, because it's got the full conversation history. It's not really conversation, it's a series of commands and responses, but I'm just using the conversation history to keep track of what it has done in the past. So there's that's sort of a simplified version of these autonomous agents. This is the more complicated version. So these more complicated ones, the Baby AGI and the Auto GPT, they have sort of a few different GPT components. So they've got the user first provides the objective and task, puts it on a task queue, and then they've got this loop with an execution agent that runs a task creation agent that looks at the result of the task and adds tasks to the task queue, and then a task prioritization agent that prioritizes the tasks that are remaining in the queue and sends it back to the execution agent to execute. So obviously that's heaps more complicated. I don't really want to go too much into this stuff tonight, but I do think it's definitely worth mentioning. So go check out these Baby AGI and Auto GPT. They basically do the same thing as my repo, except a lot more sort of features and stuff like that. I think, in my opinion, it's a cool little experiment in what can be done. I think we might be looking at sort of the future of where we're headed, but I also think we're not there yet. The main use case I see this being cool for is research, because these things can search the internet. If you ask them to, research a topic for me, it's going to be able to search Google or go to Wikipedia or whatever, get information out of those things and put them into a referenced essay for you. Maybe you're doing school homework or whatever, it would probably be useful for that. I don't think it's going to be useful for too much more at the moment, because if you think about it, if you sort of hired maybe a personal assistant to do this work for you, you wouldn't let them decide how they do the work and when they're finished the work. You would want to be the one sort of setting all those expectations and guidelines up front and making sure that they adhere to what you're asking them to do. So that's why I think my Treasury example is a lot better of an example of how we can use this productively, because in that it's very much guardrailed against doing anything weird, because all it does is write a blog post and then we've got all the code around it to make that blog post appear in my blog, right? We're not just asking one of these agents create a blog, because if you do that, every time you do it, you're going to get a totally different result and it's not necessarily going to be what you actually want. So I think it has to be a lot more directed in order to be productive at the moment, as per that comment. So that is all the stuff I wanted to talk about in terms of where we are at the moment. Now I just want to give you a sneak peek into the AI-powered future. So based on, if you remember back at the start, I said my secondary objective was to let you know where I think we're headed and why I think it's a lot closer than a lot of people think. So let's just sort of quickly recap what we can do with GPT-4 today. So we can write code, as I demonstrated by the fact that all the examples tonight were completely done by GPT-4. It can definitely write code. It can run, Git commands. It can clone, edit, push, pull request, all that sort of stuff. The things that developers do on a daily basis when they're contributing to a code base. It can run commands. So obviously, if you want to build it, if you want to run a suite of unit tests, if you want to do whatever other commands you have to do in the course of your development, it can redo the writing of or creating of content based on errors and feedback, as we saw with my pull request trigger. So that could just as easily be coming from, it tried to run unit tests and it got message back saying, oh, you failed this test because of XYZ. You could just as easily be feeding that feedback back into GPT-4 and getting it to rewrite the function so that it passes the unit test correctly, for example. And we've also seen that we can feed the output of GPT-4 back into itself, so it can just sort of run in a loop. So if we can do all this stuff, it sort of leaves you wondering how much work is actually required by a human to actually develop an application, right? So that's why I think the future of AI-powered development is a lot closer than we think. So I want you to imagine a world in which a developer, all they have to do is define PBIs. Maybe they're not even a developer, maybe it's a product owner that does this. We've got a GPT agent that picks up PBIs. Now, what it can do is examine the PBI that gets created in the backlog, and maybe it can ask follow-up questions. So if it decides, oh, this PBI is not well defined, I'm going to leave a comment on the PBI asking for more detail. And then it goes back to the developer to add more details to the PBI. Once it's happy with it, it's going to clone the repo, make the changes to the code base. It's going to push the updated code back, create a pull request, and then it goes back on the developer to review the code. They can request changes, just like I did in my T blog, and that can trigger the GPT agent to do an update. And then once it's done, that's it. So really, what is standing between us today and this system where all you have to do is tell it what you need, and it's going to do it for you? I think not a whole lot, actually. So this, it might be coming soon with the new GitHub Copilot X we'll see what that sort of thing can do. But yeah, I don't see a whole lot standing between us right now and this sort of completely automated solution where developers don't actually have to write any code at all. All they have to do is review it. Maybe there's a couple of lines here and there they have to do where GPT-4 agent hasn't done a good job, but for the most part, I think, especially all the regular boilerplate code that's the same in every app, I think won't be a thing we have to do for much longer. And then the other thing I want to discuss, the future of AI-powered internet. So this one, we're looking a little bit further forward into the future. We're definitely not there yet. It's not as close as the development I just showed you. So I've got this project, another public repository called the GPT server. And basically the idea behind this is we prompt Chat GPT with a prompt saying, you're a web server, you receive a route for an HTML page that the client requests, reply with the full HTML for the page. So basically what we're doing here is we're running GPT as a server, and then based on the route that we pass in, we return back the full HTML for the page. And the way that I set it up was that we're doing a multi-turn prompt, right? So we're storing the conversation history of the pages that got generated. So that way, for example, when I click on the web design link, it opens a web design page and it's in a cohesive design because it knows, all right, this is what my homepage looked like. So this is what my web design page looked like, right? Then I can just type a random URL in there. So I type in blog/my thoughts on GPT-4, and that gets me a generated blog post about my thoughts on GPT-4. This is my favorite feature, is if I restart the web page, it gives me a whole new homepage, because obviously that clears the conversation history. So it starts a new conversation, which means it's going to generate a whole new response. And yeah, so I've made this repo public as well. You're welcome to go have a look. It's very simple, because all it's doing is giving that prompt, and then based on the incoming route requested, it just sends the response from ChatGPT, the HTML response, back to the client or the browser, and displays it there. So very simple. And I think potentially, yeah, we might not be going to a world where entire websites are generated like that, but potentially at least significant portions of web pages or certain areas where it makes sense to do it. Obviously there's going to be a bunch of stuff that is static that never needs to be changed, but there's no reason why, I guess, if this was fast enough, you would need any server-side application at all, right? If you can generate the HTML output fast enough, why even worry about any of the app code that generates the HTML when you can just have GPT generate it for you? So like I said, it is definitely further into the future though, because you've seen how slow GPT-4 can be when it was working on that pull request. I can show you that summary, that README of my GPT server app, and it looks really cool, but actually each of those pages takes like a minute or two to load up, right? So it's sort of reminiscent of using broadband to access the internet. But that's where we are now. Who knows where we'll be in 5 or 10 years or whatever. So yeah, so we could use data embeddings or API to inform the content on the page. So obviously we wouldn't necessarily create a whole new random page every request. What we'd do is go look up some embeddings or an API or whatever, and use that data in the prompt that generates the HTML, so that the page that we create is actually representing the information that we want it to. We can also use stuff like the user's preferences to inform that content. So if we know what the user's intent is in browsing our web page, we can make sure that the response that we give them is aimed at helping them achieve that intent. And then the other thing that we can think about is not only on the server side, but also on the client side. So why not have a GPT-powered browser that understands what we're trying to do when we're browsing the internet, and is able to read data from a variety of sources, collate that together for us, sort of like Bing Chat does now, except instead of a chat interface, it could be generating an HTML page for us or whatever other markdown language of the future there is, based on our need or our intent. And that way, sort of servers and apps will inform the content and so on, but they're not going to enforce the layout. So the way, obviously, internet browsing works at the moment is the server tells you the HTML of the page, and that's what you browse. But I see a future where the browser actually decides what the format is based on the need of the user. And I imagine it will look something like this. So we've got a user with a GPT browser. We've got a bunch of GPT servers. Now, it might not be GPT, by the way. It might be some other language model of the future as well. But I'm just saying GPT because that's what we're using now. The most important thing in this scenario is the data source, right? So the data is the one thing that GPT can't help with. It can't make up random data. Otherwise, there's no point in trying to browse it because it's not real. So the data is the important thing. Everything else is sort of the user is browsing information with GPT. The servers are creating their pages with GPT, and they're just sort of meeting in the middle. And that's sort of like where I see us headed in terms of the future of apps. But like I said, that's definitely further in the future. But the GPT-powered development definitely that definitely isn't far off at all. And thank you. Yes, thank you. So I do have a feedback form. I would encourage everyone to scan this QR code. If you are watching on YouTube, there should be a link. I think they pinned it to the top of the conversation. So just click on that link and give me some feedback. I do want to hear feedback as much as possible, the good and the bad, so that my next presentation can be even better. Let me move that out of the way for you.
Thank you, Callum. That was one extraordinary talk. All right, welcome to the Q&A with Callum. I have a bunch of questions here, so I'm going to hit you with a few.
Okay.
And the first one I've got here is, what got you into Chat GPT? You were obviously quite deep into it. What triggered you to get into that on the side while you're doing software development and made you believe this is it?
Sure. Well, I think there are actually a couple of things that got me into it. Firstly, previously I was definitely into low-code development. So if you remember, I'm very much a believer in working smarter and not harder. I think low-code development is a way that you can do that because you get a whole bunch of stuff out of the box. You just tweak it to do whatever the client needs. From day one, you're already solving their problems, and you're not wasting, a sprint or two just setting up all the basic stuff. You've already got it, and you're just building on top of it. So the same reason that I'm interested in that, I was interested in GPT. Then the other thing was, I've always had a problem where I've got a lot more started projects than I have finished projects. So it's very easy for me to, come up with ideas of things that I want to do, but it's hard for me to find the time to actually finish them. So I found the ability that GPT-4 especially gives me to finish projects. Like I said, these, the SharePoint web part, I did that in one afternoon after work, whereas that obviously would not normally be possible previously. So I guess the efficiency boost out of using this is really great for me. So
Okay. So let's take you back to not your low-code days, but your software development, C#, JavaScript days. How does you doing that type of development with GPT compare?
yeah, interesting question. I think obviously using GPT is a lot easier because all you have to do is explain what you're trying to achieve, and it gives you a whole bunch of code. You just copy paste that code into the into your files, and then you run it. Whereas even if you're following a tutorial or whatever, the code that's in the tutorial achieves what the tutorial does and not what you want to do. So it's very easy I found GPT to sort of give you code that does what you want it to do, which obviously saves you a lot of time when you're putting it into a project.
If
Yeah.
you were to step back now, because you've got used to it for over a month now, how would you feel if that was just taken away from you now?
Well, obviously, I would be disappointed, just like anyone who has experienced something better and then lost it.
Right. Okay. So let's move on to your low code days,
Yep.
where you're a lot more productive. How does ChatGPT? What's the experience with ChatGPT?
Yeah, I actually think that the existence of Chat GPT is sort of an existential problem for low code solutions, because if you think about it, developing with Chat GPT is really a low code solution, because all you're doing is giving it your requirements and then it gives you the code. But it's got a very big advantage in the fact that it's still code that it's given you, right? So the problem with a lot of low code solutions is there's limitations in the low code platform that you're using. You can't always do whatever you want, right? But if you're dealing with code that has been generated by GPT, if you want to tweak it, all you have to do is tell GPT to tweak it, you tweak it, right? But if you're dealing it with low code, if there's a limitation to the platform, you just can't get around it, and that's just a problem.
Right. Oh, that's amazing insight. Now, we have a journalist up the back who said that they understood everything except the Auto GPT.
Yep.
Can you give it another layman's explanation?
Yes. So the Auto GPT, I guess, if you imagine that that you were talking to Chat GPT and you asked it to achieve something, like write an essay about or write a journal article or whatever journalists do about environmentalism or whatever. What it would do is, or what you could ask it to do, is break that objective into tasks. So it might give you back things like research environmentalism, come up with a catchy introduction, write the body of the thing, come with the conclusion. So you've got a list of tasks, and then what would happen would be you feed each one of those tasks back into Chat GPT and say, okay, now that I've got this task list, give me some research on environmentalism, and then give me a catchy introduction, give me the body, give me the conclusion. So each of those tasks, you sort of break it down like that and do each one sequentially, and then you put all that stuff together as a result. So then the next step is, rather than you manually doing that with ChatGPT, the whole thing's automated. So you just tell Auto GPT, hey, write a journal article about environmentalism, and then internally it does the whole process of break the objective into tasks, run each task individually, and then stitch everything together in the result. Does that make sense, journalist? Yes. Okay, good.
All right. I got another question here from Yuli. Data cleanup. Could I use ChatGPT to find like duplicate rules or in content or in meaning, because you've got that graph? Is there a way that you could, use it to kind of group similar rules together?
Yeah, totally. Next question.
Okay.
No, obviously.
How?
So, you saw on the diagram, we can cluster the rules together based on the semantic meaning of the rule, and obviously, rules that are close together in meaning are going to be close together on that graph. So we can easily sort of generate a bunch of clusters based on their locations in the multi-dimensional space, and yeah, so you could detect you couldn't detect necessarily duplicates, but you could detect rules that are very similar in meaning. So that might be a duplicate, or it might not be a duplicate. It might just be another rule that says similar things, but might not necessarily be the same.
What about contradictions?
Contradictions, not really. So all the embeddings do is they tell you the meaning of a rule. I think it would be difficult at least using embeddings to find contradictions. You might be able to use GPT to automatically find contradictions by feeding in a whole bunch of rules and asking it, hey, do any of these rules contradict each other? But that'll be a whole other thing. So we wouldn't use embeddings for that.
Would this be potentially an application of Auto GPT with a script to do this?
Potentially. Like I said when I was talking about Auto GPT, I don't think it's that useful at the moment because it is going to set its own sort of objective of or finish state of when it says it's done. And it's going to set its own method of how it achieves the task. So I think if you just said, find contradictions in the rules, the output that it gave you would not be very useful. Although, of course, you're welcome to try it and let me and prove me wrong, but I think it wouldn't work.
All right. Next question from Matt Wicks.
Yep.
ChatGPT famously can't do maths well.
Yep.
So I don't do maths because I've been told it's dangerous, but I just did a quick one. Pick two random numbers between 1 and 5. Tell me what they were, then times them together. It said, all right, I picked it. I got 3 and 4. Now multiply them together. I get 12, so it seems to work.
Yep.
But I think if you make them big numbers, like 5-digit ones, it will fail.
Yes.
So his question is, Callum, how long will it be before they learn to multiply better?
Well, interesting question. So using just the language model, obviously it's not a mathematics model. So the way that it would answer a question like 3 times 4 is based on its training data. If it knows that 3 multiplied by 4 is 12, it knows that it's 12, but it doesn't have any idea what that actually means. So if you increase them to 5-digit numbers, where these numbers are probably never in any source material anywhere, it's got no idea what they are when it converts them into tokens. So it's got no idea what happens when you multiply them together. But what we could do, if we wanted to have a model that does maths, is get it to identify when some text represents a mathematical equation, and then be smart enough to integrate with an API that would multiply them together and return the result, and then insert that back into the reference data, just like I did with the rules. Instead of looking up embeddings for rules, we could just say, all right, these are 2 numbers. We know from the context that it's trying to multiply them together. We have a math API that can multiply 2 numbers. We send them off there, get the result, put it back in the reference. So it's definitely possible, just not using the language model alone.
Okay. All right. I'll combine about 4 questions here.
Okay.
One was from Seth here. How far away do you think we are from a company having an internal GPT chatbot for employees to use that's accessing all the company's information? And is it secure enough to keep it private? Similar to, I'll let you answer that one first.
Well, the first part of the question, how long until we can do it? We could do it right now. So the thing that I showed you, that the embeddings example, all we did for that was we didn't train it, but we provide it with the embeddings of all our public SSW rules, and it acts like a chatbot, so it can answer questions about the rules. There's no reason why you couldn't provide it with embeddings of all your internal documents, or your client information, or your people information, or whatever you want, and then the chatbot's going to be informed by those responses. So you could do that right now. Second question about privacy, that's sort of more of a curly one. So the information that you send into OpenAI, I believe they keep it for 30 days on their end. So they do, well, at least according to their policy, they do remove it. They apparently do not use it for training anymore. They used to use the data that you send into the API to train their own model. Apparently they don't do that anymore, and apparently they keep it for 30 days, I think. Have to double check that. But I guess it would be up to you whether or not you feel comfortable with risking sending all your private information, because obviously every time you send a query to this chatbot, the data is going to be transmitted to OpenAI. They're going to give you the result. So
right,
that'll be up to you.
And how would it work if you've got like a mix of private and public? So you might have the rules, which is public, internet content, but you want it mashed together.
There's no reason why you couldn't do that. So the embeddings chatbot that I demoed before, it has no idea that these rules are public, right? All it knows is these are a bunch of embeddings. I'm getting some reference data from somewhere. We provide it with the reference data based on the embeddings, but when it gets up to the chatbot, it's got no idea where the reference data comes from. All it knows is this is reference data. So we could be sourcing that from public rules. We could be sourcing that from private documents. In fact, I see a future in the near future where every website could have a chatbot on it, and that chatbot could be informed by all the pages of the website. So, if you've got a website with company information, it could have a chatbot that you would just plug in. It would automatically index all your pages, all your content, and use that to inform the chatbot. Because the implementation that I demoed with that embeddings chatbot, that is very generic. There's nothing SSW specific in there except for the data that's sitting in the database. So that data in the database could be anything. It doesn't have to be SSW, right? So there's no reason why you couldn't use that for anything.
All right. Next question. How much success have you had getting it to answer super specific questions, like, do you use parentheses on check by? So there's a rule about check by. So do you use parentheses or not?
I guess it depends. It depends what the specific query is, right? So if it's it depends both on what the query is and what the scope of the training data would be relating to that query. So if using parentheses on check by was a thing that everyone did, which obviously it isn't because at SSW it's an internal policy. If it was, then it would probably work fine. But since it's not, I highly doubt it would work at all. If you provided the reference data that told it every time you see someone checking an email, it should have parentheses around it, and provided that to it in the system prompt, then I would imagine it would work. With GPT-4, that sounds like one of the things that if you tried it with GPT 3.5, it might not work all the time, but it would probably be consistently working with GPT-4.
Okay, all right. I got another question here. Can it already iteratively improve its own code without human intervention?
What is it?
GPT.
Good question. I'm not sure. I got no idea.
Okay, all right. By the way, Wolfram, yes, might have been a good answer for the maths one.
Yeah, sure. So that could be. I think actually back in my screenshot of Chat GPT plugins at the start, there's the Wolfram plugin. So yeah, that would be a use case for that plugin. Would be answering maths questions.
All right. I'm not sure if this is a product idea, but how about you make a Scrum Master GPT, use a voice generator to ask you the Scrum questions and automatically collect the retro information based on blockers and user positive or negative comments in the meeting?
Yeah, 100%. You could do that right now.
There you go. JK, you build it. Okay. Now, have you had, tell us about the funniest conversation you've had. Have you laughed out loud dealing with GPT?
My favorite thing to do with Chat GPT is ask it to talk like a caveman, because it says some really funny things. Exactly. I told it to describe tonight's user group as a caveman, and it said something like make tribes smart together, something like that. It's always funny. So I would say if you want to laugh, just tell it to explain something as a caveman, and it's always funny.
So one of the things I've always struggled with, we have a rule about being a standards watchdog. So when somebody does something wrong, correct them, etc. Callum gave me a couple of things like act like a dog and tell the person that they got this, and this wrong. And it starts off by, hey Yuli, woof woof, it's your friendly standards watchdog here. I know that you might be barking up the wrong tree here, but blah, blah, blah. It's really fun way of reading a correction email.
Yeah, it's easy to give someone corrections like that if you do it in a funny way, I guess. So, yeah.
Okay. So let's talk about two scenarios of the future. Let's just say you're a blog writer or a social media person or whatever.
Yep.
And you're now working for a startup selling, I don't know, green juice or something. What would you be doing if you were them? And what's the year ahead going to look like?
Well, I would probably be looking at sort of automating the entire content creation process. So in terms of if I've got a blog, I'd be automating that. If I've got social media posts, I'd be automating all of those. We could line them up together. So we create a blog and then we write a tweet or a LinkedIn post about that blog. All that we could do right now. The one thing we might struggle with at the moment is image generation. So you saw on my blog, the images are the sort of letdown at the moment because they're not super great. So you could at least generate a description of an image. You might still need a human intervention to actually create the image or a designer or whatever for right now, but that might not be the case for a lot longer. Then the other thing that is tricky is sort of generating videos. So if you wanted to have video content, you'd probably just need to describe the video and then have someone else make it. AI does make videos today, but they're not good. They're quite obviously AI generated, so that's still a little way to go.
All right.
Yeah, so I'd be sort of automating that whole story. You could still have it so that me as a marketing person can still have input. So I'd be still prompting it on what we're doing, what is our maybe we've got some promotion that's happening at the moment. We can use that to inform a series of blog posts and a series of social media posts and all that sort of stuff. But that actual content that gets generated from there, sort of like the development of the future, how the developer just adds PBIs and the GPT agent picks it up. We could do a similar thing where the marketer just says marketing ideas and the GPT agent generates it from there.
What I probably wouldn't be doing is saying, look, I'm a great writer. I don't need that stuff. I can do it on my own. I think that'd be a bad approach. You really need to be trying to use it many, many times every day from this point forward, or you'll be in trouble.
Yeah, I think a sentence that sums that up that I saw recently was, your job might not be taken by AI, but it will probably be taken by someone who uses AI. So that's something to think about.
Yeah, it's probably like having a pilot that won't use autopilot. You wouldn't want to get in that plane with that person.
Yep.
And I've got a comment here from Wixie. The future is going to be dark. Elon Musk and 1,125 people, including AI experts, have signed an open letter calling for a 6-month pause on AI development. The letter called for AI labs to pause training any more tech more powerful than GPT-4. What are your thoughts?
Well, I don't think that's a good idea because, firstly, they could sign the thing and just do it privately and not tell anyone, and then in 6 months say, hey, we now got GPT-5, right? There's no real way to enforce it. I think it's probably just the fact that Elon Musk and all the other people who signed it want a chance to catch up. So they want to do their own development. They want to stop OpenAI so they can catch up and get a similar level of product. But it is a big potential problem that as soon as someone is able to create a self-improving AI, they might run away with everything, right? Because as soon as it's able to improve itself, there's going to be no stopping it. But I think it's sort of going to be inevitable anyway. Like you would either want to enforce a permanent lockdown on all AI research if you're going to do that, or have nothing at all. I don't think a 6-month pause would do anything. Like if you've got a long-term view, pausing for 6 months isn't going to change anything, right? All it is going to do is give other people a chance to catch up with their own potential risk rather than stop the risk at all. So if you were actually concerned about it, you'd be trying to stop all AI research worldwide, and no one's allowed to do any of it, and it sort of outlaw it everywhere. If that was a thing you're trying to stop.
Well, I think there's going to be a freaking lot of chaos from this point forward very quickly. If you saw the amount of trouble that just social media has caused on the younger generation, has been great. And this, like we saw what happened in the US with, and this, we don't know, we've got two sorts of media now. as soon as you've got these problems where you've got people generating voice of other people saying things they didn't say, which I personally think should be illegal. And you wouldn't. There's certain things you wouldn't do, like you wouldn't ever have child porn on your computer. You should never have fake voices on your computer where you're using that, because you can have real-time stuff. You can, I could have my wife call me up and say, give me the pin of this, I forgot, I'm down the shops, and this is going to be terrible. I don't think that stuff should be allowed, and I think deep fakes should also be not allowed. Like, we can do it, but you wouldn't do it. And the fact that it like I read an article about how it taught itself to chemistry basically from scratch. And if that's true, you can get it to do things we've never thought of. Go to the local Bunnings and give me some things because I want to have fun and blow up my neighbor's letterbox. Crazy things that we weren't able to do before, and you could cause. I don't think that it's going to be smooth sailing from here. I think it's going to be an absolute shit show. But
sure, well, it's definitely going to be different. That's the one thing we can be certain about.
Yes, that's right. So anyway, thank you, Callum. That was a fantastic talk. I can't wait for tomorrow when we have
GPT-5. I hope not.
Yeah, so it's been fantastic. Thank you very much, and thank you to everyone online and into Sydney, Melbourne, Brisbane, and Newcastle. That was awesome, and our China office. And I will see you for the user group in the next one. This is Callum, Simpson, and Adam Kogan signing off for SSW TV.